Welcome and thank you for attending this session at DataCon Los Angeles. My name is Dennis Torres. I'll be talking about Data Lakehouse in the Cloud, the Azure solution. This is me. I'm a data platform MVP with some Microsoft certifications. I'm a consultant. I'm the Malta Data Platform User Group leader, and you can see on the slides my contacts. Feel free to get in touch. It will be a pleasure to stay in touch. Our agenda today. We'll talk about data warehouse, big data, data lakehouse, the Azure solution for this entire scenario, virtual data lakehouse, and demonstrations. One very important concept for our companies is the single source of truth. Many companies, almost all companies, have many applications. One application for accounts, for customers, for sales, and many times these applications don't talk to each other. They are independent applications, and they are concerned about their data, their scope of the data, not the other ones. So when you try to join the information between these applications, this is not always a success. You will not always find a match between the data on this application. So you need to create a single source of truth. And this single source of truth is the data warehouse. You need the data warehouse to get the data from all these applications and unify the data in a single model that will be the business model. One single business model that usually is denormalized and used a schema such as a star schema. Many people think data warehouse is something from the past. Not exactly. Not exactly. We still need the data warehouse. The point is, everything became bigger. We have now big data. Why? Why this happened? Because internet. Because globalization. So everything became bigger. You build one small app for a smartphone, and this app can become worldwide, used worldwide. You get data from the entire world for this application. Imagine how often you get new records about data from this application being used by everyone. A distributed website used worldwide. So the size of the business becomes a lot bigger. Simple relational databases are not enough to receive this data, receive all this amount of data. In fact, we have specific architectures to receive the data from a big data environment. And we need to use these architectures, otherwise we can appear in a comic joke like this one. Labs architecture is one example of architecture used for a big data scenario. The tools illustrated on this image are only an example. You could use many different tools, but you need an entry point, a tool for ingestion of the data, in this example is Event Hub. Then you break down your data into layers. A speed layer is a layer that you show to your users the real-time data, information about real-time from your application, and this information will be discarded. Will be displayed to your users and discarded. while you have the batch layer that will store the information and will allow your users to analyze the history of data from your application. And you have Power BI as a server layer that can be used to analyze both layers. The speed layer showing real-time data and the batch layer showing the history of the data. One important point in relation to big data is that when we talk about big data, we usually talk about an MPP architecture, massive parallel processing architecture. What's that? You may imagine a database, but the point is the amount of data that you need to process is so big that you can process with a single node in the time that you have allocated for that. You need to distribute the processing. The idea of an MPP architecture is that you have a control node that receives the request for processing, and this request can be queries. A simple SQL query can be received by the control node. The control node will distribute this query among all compute nodes, and you can have many compute nodes, making a scale-out architecture. The compute nodes will all have access to the data and will all process a piece of the data, returning the result of that processing from that piece of the data to the control node. And the control node will merge the result and give back the result to the user who requested the result. That's the idea of an MPP architecture, and this MPP architecture is implemented by many different tools. Many different tools implement this architecture. In this example, we are talking about SQL queries, but we can mention many different tools. For example, Hadoop implements this architecture, Spark, SQL Server Big Data Cluster implements this architecture, Synapse Analytics implements this architecture, Databricks implements a similar architecture, and so on. The MPP architecture is a base idea for many different tools. And we need to store this data somewhere. The data became bigger, and we need to store this somewhere. Where will we store the data? So we need a place where to put the data. And the name we gave to this place is data lake. Data lake is the place where we put the big data, this huge amount of data that we ingest. And if you remember the Lambda architecture, the image from the Lambda architecture that I showed a few slides before, the data lake that we are talking about is about the storage layer, the persistent layer. And we need to care about the data lake, how the data will be stored at the data lake. Otherwise, the data lake can become a mass of data and become a data swamp. There are even techniques about how to organize the storage of a data lake, partition the data, and so on. And new technologies are being created to be used over what was usually a simple storage, and now it's becoming a special technology to store this amount of data, like, for example, Delta Lake. I will not go into details about that. But why do we call this a data lake? Because in the past, in the old past, when we had the need to process something and we had an application. That application had the need to process some data. The first thing that we would imagine is, okay, import the data to the application will process the data. That would be our idea. With a data lake, this doesn't happen. The idea is that the data is there, static, like a lake. Is stopped there. And the applications that need to make any kind of processing with the data from the data lake, they will not import the data. The data will not move. They will go to the data lake to get exactly the data they need to process. So the application goes to the data. We reversed the order from a very old past to the present. We reversed the order. Instead the data going to the application goes to the data. That's the idea of the data lake. Let's put everything together. Let's do everything together. We have a data warehouse, and the data warehouse is usually used for structured data. I will not go deep in concepts, but if you get a book like from Amon, one of the fathers of the data warehouse, you see that the data warehouse is more than that. But in many technical sessions, you see the data warehouse be mentioned as the place for structured data. That's it. Let's assume this. And we have a data lake, with the place where we store unstructured data and the big data. Why unstructured data? Because the data can be in any format. It can arrive in many different formats, packets, CSV, and not only the technical format, but the schema as well. So the data in the data lake is unstructured data, and is huge. So the data in the data lake doesn't move. And they decided to marry. A data warehouse and the data lake decided to marry. What's the result of the marriage? A data lake house. That's it. A data lake house. Many people doesn't like exactly the name. Maybe because data lake house is not one thing, it's two things. It's like a couple. They are together, but they are two. There is the data lake and there is the data house. We talk more about data lake house in relation to the tool that will use this data. Because you have tools to use a data house and you have tools to use a data lake. If you can use both data house and data lake in a single tool, this will become great. So, a data lake house has structured data, unstructured data, and the big data together. Let's talk about Synapse Analytics, a new tool provided on Azure, and the Synapse Analytics has exactly this capability to allow us to work with a data lake house. How Synapse Analytics allows that? Synapse Analytics use pools. So we can query an Azure Blob Storage using a on-demand pool. It's a serverless pool. It will not even be charging us by minute. It charges us by queries. And the possibility to query an Azure Blob Storage is just an example. We can query many different data sources using an on-demand SQL pool. But Synapse Analytics also has a dedicated SQL pool. A dedicated SQL pool is like a SQL Server database. You can look to a dedicated SQL pool like a SQL Server database. What's the difference? Why it's not SQL Server? Because this SQL database uses an MPP architecture. You think you have a database, but in fact you have 60 databases distributed among many nodes using an MPP architecture to deal with a huge amount of data. And the dedicated SQL pool is capable to work together with their on-demand SQL pool. They can access one another and query one another, and we also have Spark pools in Synapse Analytics. We have the Spark pools to also deal with unstructured data in data lake environments like Azure Blob Storage. So the Spark pool can also deal with data lakes. And we have a database to share information between the on-demand SQL pool and the Spark pool. And they all work together. These three pools work together in a single tool, which is the Synapse Analytics. So we have the data lake in this tool, and we have the data warehouse in this tool. One single tool used to work with both scenarios, with a data warehouse, a huge data warehouse, and a data lake. And let's remind the classic data warehouse solution and see how it fits on this scenario. On a classic data warehouse solution, we have many data sources, the main applications that I showed in the beginning. We have an ETL process, transforming the data, cleaning the data, and inserting the data into the data warehouse. And from the data warehouse, we create a semantic model, a data model, and we have reporting and analysis tools that you get data from the semantic model or directly from the data warehouse. This is a classic data warehouse solution. And how this solution fits together the data lake house solution that we just saw. How these solutions fit together? Simple. Instead of a data house, we can say that we have now a data lake house. This middle man is now a data lake house. And in our data lake house that I just showed in relation to Synapse Analytics, we can mention that from production we have ETL process, ingesting data into the data warehouse, using Azure Data Factory, for example, to ingest the data into the data warehouse. And we have ingestion process using Event Hub, IoT Hub, and Stream Analytics to insert the data into the data lake, and Synapse Analytics will analyze the data in the same way. So we have the ingestion process and the ETL process gets the data into this environment, the environment of the data lake house. And then comes Power BI. Power BI gets into stage. Let's talk about the Power BI solution architecture. We can have make many transformations, and we have like a self-service ETL, a very powerful self-service ETL using Power BI data flow. Of course, we are not required to use the data flows. We can just use Power Queries to gather the data set. We can, but using the data flows, it will make the solution way easier to distribute, spread across an enterprise environment. And then we have a shared data model on the data sets. The data sets are the data models. And we have the visualizations, the reports and visualization of these data models. So we see the Power BI solution architecture and how this solution architecture from Power BI fits together the data lakehouse solution that you just saw in relation to the other technologies. Simple. It's the serving layer. Power BI is the serving layer. So the data flows will get the data from the data lakehouse, but also give to business users the ability to manage this data in many different ways that the data engineers who built the data lakehouse may not have imagined. And even get external data from the company as well. So the data flows make the scenario very powerful. Then a semantic model is built using data sets, and we have the visualization with dashboards and reports. So it's the serving layer of the solution. Let's take a look on the classic data warehouse solution. If you look on this other drawing, how Power BI fits here. Power BI fits here getting all the work of the semantic model and the reporting analysis to itself. In many ways, Power BI is replacing SQL Server analysis services. Yes, Power BI is replacing SQL Server analysis services on this scenario. One interesting point in relation to this is that we have two ETLs. We have the ETL that ingests the data inside the data lakehouse, that in the past was SSIS, now can be Azure Data Factory, and we have the Power BI ETL. Why do we have two ETL processes? We have the data factory and the Power BI data flows. These are two ETL. I'm talking about modern technology, forgetting the SSIS, that could be considered as well. But these are the two ETLs that we have. Data factory is used to ingest the data inside the data lakehouse. We need an ETL for this process to ingest the data inside the data lakehouse. Of course, the ETL part is used for regular data warehouse. It's not used for big data that need to be ingested through event hubs, through an ingestion process. We are talking about a regular data warehouse ingestion on an ETL using data factory. And data lakehouse will contain all the history of the data. The data lakehouse will become the single source of truth for the company. What in the past was a data warehouse, now it's a data lakehouse. A data lakehouse being a single source of truth for the company. And the data flows are used to get the data from the data lakehouse and build data sets, build the semantic model. So we have a second ETL layer to build the semantic model. So we have two ETL layers on this scenario. And the second ETL layer builds the semantic model and allows the business users to use what's called self-service ETL. They can build their own ETL, sometimes retrieving data from outside the company when needed. They can. And data sets are the semantic model. And everything that I'm talking about is spread around the company. Imagine a huge enterprise. an enterprise distributed worldwide. Everything will be spread around this enterprise, around the entire company. What will happen? We have the main office. The main office has some branches, one in each continent: Europe, North America, Asia, and in each country we may have many different branches: Sardinia, Malta, United States, Mexico, and so on. So branches for countries, branches for continents, and the main office. What will happen? What will happen is that the countries will not be able to wait the main office to build a centralized data solution for them. So each country may build their own solution. One country may have a data warehouse, another country may have a data lake, and so on. Each country will build their own solution. What will happen when the main office and the continent branches in the main office decide to build their centralized solution? They will discover that each country already built their solution. So, how to work with this? One logical idea from the past was that we would use ETL to import the data. Import the data from the branches to the main office. That's out of the question. Especially when each country may have a data lake. And I mentioned it's a core piece of the concept of the data lake, that the data will not move. The data will stay there, and the applications that require that data will go to that data to get the data, but the data will be stable there. So what we do? We access the data in place. So the main office will access the data at the branches. And the main office can create aggregations, create different views, but will not import the data. They may create aggregations as needed, and so on. Data warehouse concept, and many of you may link in these with Power BI concept as well, and both work in these situations. And it will work without importing the data to the main office. That's what we call a virtual data lakehouse. So the main office will have a data lakehouse, but in fact the tables that we will create in the main office will be our external tables. From these external tables we can make aggregations, summaries, and so on. But they will be all external tables from the branches, from the data at the branches. So we'll have a virtual data lakehouse at the main office of the corporation. Completing this scenario, just for the scenario to be more complete, that's the scenario that we saw. I'm not including the data lakehouse view, but for the scenario to be more complete, we have there the on-demand SQL pool reading data from the cloud. That's the idea of the virtual data lakehouse. And we can also use machine learning scoring. Overall, this scenario, we can also be using machine learning. Let's talk more about Synapse Analytics, just to get more details about this powerful tool that we are talking about. This is a picture from the 80s. This guy with all these gadgets around him. And we know what's the result of this picture. Of course, we are not on that day, on that anymore. We know what resulted from this. We have a cell phone that replaces all these gadgets this guy is using. Replace everything. A simple cell phone replaces everything. That's the idea of Synapse Analytics. Synapse Analytics is a Swiss plane. It's able to do every piece of task that we need to do to get the final result in even a virtual data lakehouse. That's a solution that we imagine to be absolutely huge, but we can build the entire solution using Synapse Analytics. How this works? Data factory data flows. They are inside the Synapse Analytics. They were incorporated in Synapse Analytics. So we can have pipelines inside Synapse Analytics. Azure SQL Data Warehouse. Azure SQL Data Warehouse was incorporated in Synapse Analytics. It became the dedicated SQL pool. The Spark pool, Power BI is integrated and linked with Synapse Analytics. They can both work together, and the power of them working together is getting bigger and bigger. And Azure Machine Learning also integrates with Synapse Analytics. We can also make an integration between Azure Machine Learning and Synapse Analytics. So this allows Synapse Analytics to make the complete scenario of a data lakehouse and a virtual data lakehouse as well. The idea is that the user, the professional who will be building this architecture, will not need to be specialized in so many different tools. He can focus in one tool, and we can summarize this saying, we are killing the Alt tab. The guy will not need to be using Alt tab to go from one tool to another tool to another tool to another tool to complete the work. The work will be possible to be done in a single tool, Synapse Analytics. Let's see a demonstration of this entire environment. Let's see how these work together. Here I have a Synapse workspace called Malta Lake. This is my Synapse workspace. I can check here the pools that I have inside this workspace. I have a dedicated pool. I have a built-in serverless pool. And we have an Apache Spark pool, multi-Spark. Also notes the capacity that it shows to this pool. On Synapse Analytics, we have the Synapse Studio. All the work is done inside Synapse Studio, and I have the Synapse Studio already open. Anyone who is starting with Synapse Analytics, the best place to start is the Knowledge Center. We can choose the Browse Gallery, and here in the gallery, we have many information, data sets, and scripts that we can try on our own Synapse workspace. We have data sets, huge amounts of data available for us to work with. We have notebooks, Spark notebooks that we can use to process our data. We have SQL scripts for our dedicated SQL pool or built-in serverless pool, and we have pipeline for data factory to make ETLs, to build ETLs from some existing pipelines, ETL pipelines. We can get an existing pipeline and use as an example. Let's close the gallery, take a look on data, And I have here the dedicated SQL pool. And I have a database called New York Taxi on the serverless SQL pool. So here I can see the database that we have. On the Develop tab, we can see many scripts or many developments that I already started, I already left here saved to gather the Synapse workspace. Let's start here on the folder Data Lake House. I will start talking about the Synapse serverless SQL pool. First, how a schema is built on the Synapse serverless SQL pool. Here, I have the creation of a database scoped credential. Then I can create external data sources. I start with external data sources pointing to external locations. I have one external data source pointing to a blob storage that is on my Azure subscription. This belongs to me, but this second blob storage is an open data source that belongs to Microsoft. Microsoft provided this other one to us. This belongs to Microsoft. So I'm creating a view over one of these data sources, the data source from Microsoft. I'm creating a view. There are some details about performance and optimization that sometimes in some situations make a view better than a table. And to create a table, which is called an external table, we need to define the file format as well, Spark compressed. I created this file format, and I'm creating the external table. Let's take a look on the database to see the object that I have here. External holidays as external table, and I have the view DBO trips VW. It's a view. So I have here another script called Virtual Lake Query. On this query, I'm using a CTE, a common table expression, to get information from the trips view, grouping and filtering the information, get information about the holiday, filtering the information, and joining both sources and making some calculation in relation of the number of trips during the holiday. And I can execute this query. Here I have the result of the number of trips per day and the number of trips on holiday days. And I can build a chart with this. Let's build a column chart and take a look on this result. The holidays are very well highlighted among all the days of the year. And we can notice that on most holidays we had less trips, way less trips than the surrounding days. So we can notice that the holidays affect the number of trips. And how we made this analysis? We made this analysis reading data from a data lake that is on my Azure subscription, another data lake that belongs to Microsoft, joining both together and getting the result of the analysis. That's the idea of the virtual data lake that I mentioned. I said each branch of the company on different countries could have their own data warehouse or data lake, and we would not move the data. We would go there and get the data when we need them to analyze. We would not move the data, and that's what I'm doing here. Let me close this example and Thank you very much for attending this session. Feel free to get in touch, connect, and ask me any additional questions. Thank you very much.